and welcome to the nth edition of the Hack the Planet podcast, the only podcast that makes Defender take 100% CPU for 20 minutes while compiling a report and then nags you 5 times. Are you really sure you won't let me upload this? We are here in the studio with our most of our usual panel. So we have Max. Hello. We have Mitchell.
What's up?
Daniel.
How's it going?
And I'm emceeing today. This is Ben. We have a little bit of an agenda today, but not too much. So we're going to deviate from our usual format of formless ranting, and we're going to have a trip report from the Platform Security Conference from Mitchell.
Hey, how's it going? So we and actually a couple other members of our panel were at the Platform Security Summit recently in beautiful Redmond, Washington, the not suburban hellscape of the Microsoft campus. And we were hanging out with some very intelligent, cool, genial folks in the embedded software and the hypervisor platform sort of interface space. And a lot of good ideas were shared. A lot of topics were discussed. It was a very open Q&A style summit, sort of experimental style conference, and I think everyone who went enjoyed. Would you, Daniel and Max, agree?
Yeah.
It was a very high quality conference.
It was super high quality. It was that perfect sort of balance right in the middle between like full on hardware conference and sort of like recon where you're decapping chips and sort of getting into low level exploits. But this is more focused on the engineering side of the security problem, attempting to protect against various attacks against hypervisors and the systems themselves.
Yeah, it was definitely a Defender-focused conference.
Right. So you had a bunch of folks who were building platforms. So you had representatives from Intel, you have representatives from IBM, who recently just basically gave the licensing rights for PowerPC to the Linux Foundation, and they talked about that a little bit. There were folks who are working on new styles of mitigations for instruction set architectures. There were people who run operating systems meant for use by high-value targets and hardened operating systems that support that. Cubes, if you're familiar, a bunch of folks from the Cubes ecosystem were there. And yeah, so it was a lot of people in the open source world just kind of like trying to nag all these vendors saying, hey, you know, this is why we sort of care about all this stuff in a lot of ways. How can we help us help you, or how can you help us help you? And a lot of that style sort of like conversation.
So what were some of the interesting talks you saw at this conference?
Very good question. So I think it was a really excellent talk about sort of the idea of Cheri, CHERI. I can't remember exactly what the acronym stands for right now, but it's Capability Hardware Enhanced Risk Instructions. So the essentially is adding an extension to RISC ISAs that allows you to tag pointers with capabilities. So you basically have read, write, execute, and a floating point range from which you can sort of like specify these capabilities relative to the pointer itself. These pointer tags aren't addressable in the instruction set. They can only be managed by the hardware. And the instructions for managing the pointers are basically allow you to only strictly decrease the capabilities of a pointer. So
the tags are floating point.
Yes, they did mention that, and so
that's interesting. So I didn't see the talk, but I read a little bit about it, and as I recall, this requires changes to the hardware and the compiler, but I didn't quite understand sort of how it worked, right? Like how did the pointer protections get configured originally, and then where are they enforced?
Good question. So the pointer protections presumably will be added by the compiler that sort of has information that it can infer about basically what the properties, the liveness properties of the pointer are. And then they are sort of set with instruction codes, presumably around a malloc where you could re-implement your malloc to do the same thing if you're talking about dynamically managed memory. And So it's a little of all of the above. So you probably have to rewrite your malloc, you have to rewrite your compiler, and then additionally, one thing that you have to do too is if you want to do your whole system like this, you have to modify the kernel ABI to allow for these tagged pointers to be passed back and forth between user space on syscalls.
Okay, so I'm too stupid to really get how this works. Could you give me like a concrete example of some sort of attack that this would break up?
Yes. So let's say that you are trying to do a jump to a new place relative to some pointer in memory. The hardware will check if that is a valid jump destination, for example. Well, actually, I'm not sure, because that's a little bit different than read, write, execute. So that is a very good question, and so maybe my understanding of this isn't as detailed as it could be.
Well, so I mean, I guess if it's read, write, execute permissions on pointers, then it would enforce read, write, or like if you tried to do a write and it was read only, the hardware would catch that.
Yes.
I suppose. So, but it would be the responsibility of the software to tag each pointer with like pointer ACLs.
Essentially, yes. And so they actually gave a graph of saying you can't do this for every pointer. There's some shared memory that you sort of like, you can't have necessarily strong assertions about what the sort of range of values relative to that pointer are. And so you just sort of have like a no-op. And so they basically graph, saying that some pointers have a valid range of like, let's say, 2 to the 4 or 2 to the 8, and then some pointers have all the way up to, like 2 to the 22.
This kind of strikes me as like a sort of an idealistic security solution. Like if everybody did, exactly what they were supposed to do and use the new technology, then these problems wouldn't exist. The security vulnerabilities would go away. But the problem is that if everybody did what they were supposed to do now, there really wouldn't be many security problems anyway. Right. So like even with the hardware we have, if all of the software was setting up, ACLs and, minimizing the attack surface and having, reduced privilege for everything, if everything was just configured correctly, there would be like 99% of the security problems just wouldn't exist.
I mean, yeah, if people knew how to program, then we wouldn't have jobs, but nobody knows how to program.
Yeah. Well, so the what I don't like about this, I mean, it sounds cool, like maybe it's something hardware should have integrated in the first place. But what I don't like about it is that it requires, it puts the onus on correctly, handling memory on the software developers, I guess. But that might be unavoidable.
Well, so from what I understand, it's sort of the it's sort of like coloring the target destination or various segments of memory. It sort of like gives you an additional filter, essentially, that is more flexible than the simple bit mask of read, write, execute.
Yeah, well, you can kind of do the same thing now with just memory pages, right? Like memory pages can be, read, write, they have read, write, execute enforcement. So this just gives you.
Well, sure, but also with memory pages, for example, you could probably make changes to hardware if you really wanted to. But if you're like doing a ROP attack that eventually you call like virtual alloc, and you like change the flags on a page to make it writable instead of non-writable anymore.
As you do.
Right. The hardware talks about strictly decreasing capabilities. So.
So the new thing is that the hardware would basically not let you. Typically when you do a virtual alloc, you allocate a chunk which is readable and writable but not executable, and then you write to it, and then you remap it just writable and executable, or readable and executable but not writable anymore, and then you can execute it, right? But that's a common behavior in normal programs as well, not just shellcode,
right.
At least on Windows. So I'm not seeing like a good lever in this technology to really do something different on.
Well, I think
so.
At least for Windows.
Sure, I guess I think part of the difference is that your abstraction's a little different. You have pages and then you have pointers, and so the level at which you're enforcing ACLs is somewhat distinct. I'm not experienced enough in the technology to know what that buys you or if it buys you anything.
Yeah.
So just for my own edification, Mitchell, we're talking about the like configurable ACL mechanism that was on day 3, right?
So there were multiple talks on this vein. There was one where you could have arbitrary sort of runtime checks on every instruction, and then there was one where they built specific extensions to an ISA that are not sort of arbitrary.
This is the specific ISA extension, not
Yes.
not the open-ended one. All right,
Yes.
then I'll save my comments for the other one.
Oh well, we can.
Yeah, might as well move on.
Yeah, let's move. Well, let's move off this. So what's another talk you saw at the conference?
Well, so we should talk about this other one, which was just like very pie in the sky, and it was someone from basically a contractor
Man,
for
if
the.
you were worried about the first one, this one's gonna be way funnier.
Well, the first one sounds reasonable. It sounds like it sounds like something that could be really, really useful, and I don't quite get it. Right?
Yeah.
Sure.
Yeah.
Yeah, they recompiled FreeBSD user space and kernel space, and like they said, oh hey, here's how we stop this, and here's like a graph of how much pointer protection we could have. And like, that was cool. And then you had this next talk, which was, let's say that you are a person who runs hardware and software that runs in an environment where you might not be able to change it out for years at a time, but at least the hardware, but you need to be able to make better guarantees about the hardware ABI that, you know, sometimes there will be a new thing that's added, like an IOMMU or like SGX or various other extensions to an architecture that you add for security properties, and you need to update that on the fly, and you don't necessarily own the microcode sort of like process. So what you could do is you have
on a RISC system, you don't even have a
right, yes.
microprocessor.
So what you could do is you have a coprocessor that at every instruction will trap into this coprocessor and will see if the following tuple is valid: the opcode, the first operand, the second operand, the instruction pointer, and one other that's sort of going past me right now.
There's an environment variable.
Stack pointer, maybe, or
There's an environment variable that was stored in the memory, so you can set the stack pointer in the environment variable. That's more.
Okay, yeah, but essentially the idea is that you can write arbitrary sort of instruction correctness schemas that you enforce at runtime. And so that sounds really awful. It sounds like it would really slow your programs down. But what they do is they have this neat trick where they say that every rule that they generate will always evaluate to the same yes or no instruction is allowed or not, so they cache that. And so it slows up your boot up time, but they say that you can have, you know, on the order of 10% or less overhead after you've warmed the cache, and you can have these interesting things, like you can do control flow integrity and, like, you know, whatever you want. Not whatever you want, they're still exploring, you know, various schemes that you can write, but that was the goal. So on every instruction, you trap into this other processor that evaluates whether the instruction is valid or not, and then it either interrupts or it hands it back to the regular sort of processor.
I think I recall my snarky comment to colleagues during this talk was, "We've reached peak cycles."
Yeah, one of the big downsides of the system is that it is running as a co-Turing complete processor. So, but the rule language is not Turing complete, but it still requires essentially looping over a set of rules. Which means for every instruction you have X number of rules to validate, and if you do get a cache miss, then you're going to sit spinning on the same instruction for a little while before you get like the proper exception back.
So yeah, historically speaking, having a security coprocessor be so complicated that it requires a like Turing powerful computer. So that was actually considered such a risk in the old days, because if you require a Turing powerful security coprocessor, its firmware has to live somewhere. And until a few years ago, there wasn't, they would just keep it on commodity flash or something, and you could just access it directly, the same way you access the firmware for the main CPU. And then there was a sort of the era of the, like Infineon TPMs and stuff as basically ASICs with keys burned in. And that's actually kind of turning back the other way with the new cell phones require secure elements that are like global platform compliant. And those are actually microcontrollers that have a kernel, which is supposedly protected, that has burned in keys, and then they also run applets in like a user partition.
I mean, all cell phones for a while have required some version of that. That's your SIM card is that.
Yeah, your SIM card is like a mini version of that. The new ones are actually kind of like multiple SIM cards hosted in a virtual environment. So the coprocessor is getting even more complicated, and it's moving even farther away from the having a simple ASIC, and so and a lot of that's to support the new kind of like 5G stuff that's going to require multiple keys. But the other main failure of this was the sort of the Intel ME, the Intel AMT program. Where they added a security coprocessor to the motherboard, and then it started out being this esoteric chipset and rather difficult to reverse, and eventually they made it into an x86, and then it was very famously hacked.
I thought it was still running on ARC4 or whatever that weird instruction set that they bought. It's x86 now.
Yeah, they switched it to x86, and then it was in the next year's Black Hat.
Okay,
basically.
We're going to ring -22222.
Yeah,
Everyone remembers
I
that.
one,
I think that was the
talk
top.
lead up.
Yeah. So the and the other thing this kind of reminds me of is in intrusion detection systems. For detecting network traffic, the more rules you have, basically all of the rules you have to detect things on the network get compiled into one giant regular expression. And in terms of time complexity, if I'm generating traffic, I can generate traffic in constant time. I can basically fill a buffer and just send it out as quick as I can. But if you're analyzing traffic, the best you're going to be able to do you have to run it through a compiled regex. And if your regex is like perfectly balanced, which it won't be, basically the best you're doing is like log n, right?
That's fun. I haven't dealt much with IDSs, but
Yeah,
I mean BGP is Turing complete. Like it's a Chomsky. What is that? The higher level Chomsky language classified.
Turing complete is the higher level language.
Bounded Turing complete.
I think we're talking about different classifications.
Well, so
games,
regex
but
can't.
Regex, I think, is a context-sensitive grammar, which is one below Turing powerful.
It's
but
context-free, I think.
maybe it's context. Well, it depends on if you're using the backtrace.
PCRE or
Yeah. But yeah, it's there probably are regex extensions that make it Turing powerful, but
I think that's called Perl.
yeah. Either way, I can send traffic much faster than you can analyze it. And the other thing is, I can also send traffic incredibly slow. So whatever you're trying to detect things in, if you have some sort of buffer, if you're trying to detect something stateful, that buffer will be finite, and the attacker can always slow down enough to get out of the time window that you're filling the buffer with.
Absolutely.
So there's some kind of like fundamental sort of lessons learned from the last 20 years of the security arms race. I think that kind of apply to this. But
I also heard another good comment on this, that it kind of just sounds like a really bad reimplementation of microcode.
Yep. Yeah, you're not wrong. I mean, like one of my takeaways that I had when I was watching that talk was, why are you choosing the something that requires instructions to execute? Why aren't you choosing like a CPLD or an FPGA that will at least be able to handle extremely wide Boolean comparisons when your entire rule set language exists in order to perform, like a...
Well, they might say that's an optimization for the future.
I mean, of course they would say that. That's it's a DARPA project. Like,
well, what is the saying? All problems are solved by the addition of a layer of abstraction, and all problems of efficiency are solved by the removal of a layer of abstraction.
I like
Maybe it's all problems of design.
Okay,
So,
so
yeah.
we've kind of beaten the how do we harden our processors and coprocessors to death.
Well, actually, we haven't beaten it to death.
I'm still back on. How do we, if it still requires the developers to be hard, it's either a fail or what's the point, right? Like we have to make the if the developers still have to behave, that's a problem we haven't solved now. We haven't solved like adequately training people to not reintroduce the mistakes of the past over and over and over again. Yeah. And so all of these hardware changes, it's like, I feel great that these people have funded research positions at their friendly neighborhood megacorporation, whichever it happens to be. But I'm not super excited about any of these as a topic. Like, I don't think they're gonna like come save the day.
Of course.
No, I'm skeptical that they'll be implemented anytime in the near future. But it's an interesting.
I'm just waiting.
Depend for some definition implemented.
For some definition of implemented, absolutely. I mean, Cherry, I think, is actually going to be implemented as an ARM standard.
We're seeing more and more complexity getting pushed lower and lower in the system, and what I'm waiting for is just for one of these implementations that allow for programmable microcode to be just open enough that becomes yet another exploitation vector.
Well, that's kind of your speculative execution attacks.
Well, in that case, you're abusing the logic directly. What I'm highlighting is that if you start making microcode programmable, which in this case was kind of one of the subtle points made about this architecture, is that it is going to be configurable. It is going to be programmable. There's just I just can't wait for that to get abused. It's going to make me very happy.
As I recall, Sergey Brodis at Dartmouth, in the first few years of his security program there, him and some of his students had a talk about.
He's now heading up Dartmouth.
Oh, really?
Yeah.
Oh, awesome.
Or he's at least the research program.
Well, so he they had a talk about the dwarf debug format for ELF binaries on Linux. And they'd actually figured out how to make it into a Turing complete language. And they were able to actually execute code that were implemented only in the debug symbols of a program, and basically do whatever they wanted, like literally arbitrary computation. So that's a talk back in the archive somewhere.
Yep.
But the other thing that jumps out about me, it's why I'm not as interested in these topics, is because the financial interests in this line of research are predominantly only interested in sort of DRM use cases or protecting, streaming content, or to twist it another way, they're very interested in selling people a computer that they can't necessarily change the operating system on, or sort of access the sort of lower level of the computer that would make it useful as a general purpose computing device.
Yeah, well, I mean, in this context, I think where the majority of the funding is coming from is long-lived systems in which cost of replacement for the logic is more expensive than the idea of building in this complexity up front, right? And that making the thing configurable is actually a way of creating a more durable compute system for, say, control system of military equipment, which is, I think, the angle that majority of this research is approaching. Although I will agree with you that the commercial interest would absolutely be more focused on DRM and
Content protection.
One of the few instances of actually SGX being used that I see is from DRM.
Oh yeah. SGX for sure is people are mostly interested in it for DRM purposes. And that's why it doesn't matter that it's so susceptible to side channels, because they don't need a perfect mitigation. They're used to not getting perfect mitigations. They're just like, raise the bar a bit and we'll pay you. It's cool. That's what we do.
There's also proof of elapsed time.
Oh, well, actually, so let me stick a pin in that for 10 seconds. Because the other thing I wanted to, if you look at the last decades and decades of DARPA research, they have been fixated in making their equipment self-heal. as they
Yes.
call it, for a very long time.
Yeah.
In fact, like the whole purpose of the internet in the first place was to have like the self-healing communications network. That's like why like routing traffic was important in the beginning. So they could have not just one wire between here and there that someone could cut or bomb, right? They would have multiple wires. And if you cut or bombed one of them, the traffic would route around it, you know? But that goes forward to like the 80s and 90s. They were interested in like self-healing control systems, for like, AWACS and stuff like that. And then, now it's like drones and, who knows what, but, I just think about that and I think about Terminator 2 and I'm like,
Oh yeah, no, Skynet's definitely DARPA's fault.
Like clearly, if anyone is going to come up with the T-1000, it's going to be DARPA. And it will be the result of literally decades of very focused research. They deserve it.
I feel like Terminator Judgment Day actually finally specifically named DARPA, but that was a terrible movie, so nobody saw it.
I don't think I've seen it.
I think that as far as time travel movies go, the Terminator movies have almost no logical inconsistencies in them.
That's true. Even with the Sarah Connor Chronicles. And regardless, the writing's a bit cheesy, whatever, but just the fact that someone OCD'd the heck out of that plot, like they're more careful about their weird time travel looping canon than the Star Trek wikis. Oh yeah.
Yeah, it's the next level thing. Anyway, sorry.
You go on about that.
So we're doing a trip report from a conference.
Right. And also I should just mention the URL for the conference is platformsecuritysummit.com. We have heard from the organizers that all of the talks that were given were recorded and will be released to the public. So go watch the ones that are good, which is just about all of them. Even the ones that aren't good, they're at least fun to watch.
Speaking of the SGX and the ME, I also did want to bring up one talk. It was very awesome, given about the Xbox One security platform. And there's a couple of reasons why I loved it. First of all, it was a very interesting talk about the architecture and some of the requirements that they had, and it went over some of the attacks that had broken previous iterations of the Xbox.
Hey Max, who gave that talk?
That was
it Tony Chen?
It was Tony Chen, yeah.
Yeah. So he was one of the main architects, the security architects for the Xbox One.
Yep.
It was very good. I believe he'll be giving it at Blue Hat again if you want to see it in person, but it'll also be online for the Platform Security Summit. And it is, there's two takeaways that I had from it. One was so much shade being thrown at Intel for having an off-chip security, off-die security controller. Well-deserved shade.
That is, so we were kind of talking about the global platform, secure elements, and the discrete TPMs and kind of how that's changing. So that is sort of the main difference, is whether the security coprocessor is off die or on die.
It really is, yeah.
So that's kind of how people are looking at it now. So it's gone out of vogue, to require an ASIC, because the discrete TPMs are prohibitively slow at this point, and they're they can't host multiple applets. If you change cell phone providers or whatever, that's a problem. So the STM, secure elements like that new breed. It's really just that the whole thing is in one package. Yeah. But sorry, bit of a digression.
No problem at all. Yeah, I thought that was just one of the great takeaways. I feel like Intel needs more critical analysis.
I don't think Intel has been legitimately challenged in a long time. People have had that criticism about them for a really long time, including probably most of the people that work there. But they were the first time I heard that was I heard that they had basically stagnated technically, and that was why they had to buy all of their new technology. And I heard that at the time they bought that Israeli company that developed the core architecture.
Yeah.
And that was when I was in college or something.
Yeah, that basically saved Intel back then, because they were having trouble actually getting to the next I think it was the next nanometer process.
Yeah.
and I think AMD already had solved that challenge. Like they were out competing with the Durons and the Athlons.
I kind of feel like where they're at right now, though, it's like they really pushed the clock speed and making the process small and pre-caching things as much as possible and like pipelining things to be parallelized as much as possible, and just they've taken that so far, and then you get hit with something like the Spectre, and then it's just one thing after another, because like the way they built the chip, which they've already sold everywhere on the planet, is just intrinsically susceptible to side channels. And what happened with the rest of the world market is that everyone has moved everything into the cloud, which is by definition shared hardware. So whereas the only context that people actually care about side channels in hardware is like if you're sharing that with another user, and you don't want them, you don't want to be able to see each other's data. Like,
Yeah, and
at least you don't want them to see. You don't want other people seeing your data.
And at this point, trying to get actual metal in the cloud or in a data center is prohibitively expensive, because like smaller data centers, like they're not in ideal locations. They're not close to all of the internet exchanges. The ones that are well connected, you have to buy 92 cores at a time.
Well, it's just weird. It's kind of like a perverse incentives thing. Like Intel, for many years designed their processors so that they would show up in like ZDNet benchmarks good.
Yeah.
And does ZDNet even still exist?
I don't know. Anantech still does all those benchmarks, though.
Yeah. What is the major benchmark? Cinebench.
Yeah, and everybody bought like general purpose computers, and it was sort of like an entirely different time than now, where people buy some cheap Chromebook, or the Windows version of a Chromebook, and then like all their stuff is in a cloud service, basically.
Yeah, you need like 8 gigabytes of RAM on your main computer if you're just an average user of a computer. Like you don't need very much.
Oh, yeah. You said you need 8 gigabytes of RAM, and I was like, is that a lot or a little? I don't know anymore.
Right?
No, you can get a Chromebook with like 2 gigs of RAM, and then you just use like Google Drive or whatever, and all of the rendering happens on their hardware.
Oh, really?
I
For the
don't
most part.
know about that.
Well, like it gives you some JavaScript and stuff,
right,
but
yeah.
At the same time, you can also buy like top-end Ultrabooks that'll have 32 gigs of RAM, and you can do entire 4K video rendering in your laptop while you're riding a train for some reason, because that's a use case that's necessary.
I've not been able to find Ultrabook with 32 gigabytes of RAM.
Yeah, the new MacBook family
Oh,
is all 32 gig.
Really
Wow,
top.
sensical.
this is a fruit-based laptop company. I don't think they're not giving us any money. So.
No, they have nice screens. I will say that.
Yeah. But speaking of technology that you may or may not need, there was a very nice marketing presentation on uses of software garbage engines. And one of those included proof of elapsed time for blockchain applications. So the idea is, what is Bitcoin? It is a consensus mechanism where you elect a leader by who can find a number the fastest.
We really need a sound effect for when someone says blockchain.
We need a soundboard in general.
Like
but
sad trombone.
To roll back for a second, this was a marketing presentation given by Intel about SGX.
Yes.
So
Yeah,
So,
it was. That's right. I forgot about that.
For those who don't know what SGX is, basically Intel built some capacity into their hardware a few years ago that no one has really made much use of yet, which is well, no, they even inside of DRM, they've been looking at it, but it hasn't been very utilized. I think it was originally added to Intel TXT in like 2006, 2007, and people didn't start seriously talking about using it until a couple of years ago. So someone might be using it now, but
I thought that's what the video extensions that like Netflix and stuff was using.
yes. So Netflix is one of the really interested parties. But what SGX, we'll circle back to that. But what SGX basically lets you do is you're supposedly allowed to create a secure and encrypted enclave that is protected from other processes and system memory. And it does this by connecting to some remote service, and there is a back and forth sort of cryptographic handshake that uses some Intel signed loader to then in turn load, like, say, for example, Netflix's loader. And it can spin up an SGX enclave as kind of like a virtual secure element, and it can establish like a remote cryptographic session with just the enclave, and that would give Netflix, for example, I don't know if they're using this or not, but it would give Netflix, for example, the ability to push content keys into that enclave, and then have like the SGX enclave decrypt the Netflix stream. But the problem with SGX is that it has historically been very susceptible to side channels because it's sharing the same resources with the CPU, essentially. So that's what SGX is.
Yep. And there's been, I think, 2 iterations of it, and both of them have side channel attacks against them. And I feel, and they just haven't even tried updating recently, from what I understand.
Well, I think that's on like a 10-year release cycle. As it's like one of those Intel technologies that doesn't get updated very often.
It's TikTok release cycle.
But I think that that Netflix was not actually using SGX. I could be very wrong about this, but do you remember when Netflix on Linux only worked on Chrome Beta? And I believe that was because Chrome Beta for Linux had added TPM support. So that I know the Netflix requires actual TPMs on some clients.
On the Chromebook beta or on Chrome?
Just no Chrome, and
regular
eventually
Linux.
Mozilla acquiesced. And I remember the first time I was trying to load Netflix on some version of Firefox for Linux, and there was this nice little dialog that popped up underneath the address bar, and it said, "You must install this trusted extension in order to use media on this website."
Yeah,
and it
I'm
was
not sure.
a big binary blob that you load, and I don't know what magic it was doing.
Yeah, I'm not sure what technology that was using.
So,
like, they stopped supporting Linux again because whatever reason. But the mics are they never supported like high definition or like 1080p on Linux. They only that was only supported on Windows with the special Windows cryptographic extensions.
Netflix charges more for the 4K, so that's a moot point for me anyway. I'm too cheap. I'm too cheap to pay $2 extra for 4K or whatever.
Well, they only give you 720. That's not enough bits.
I'm not a video file. It's like my ears are too bad to be an audio file. I get the gist of it. It's just moving shapes anyway. So I've been eagerly waiting for somebody to try to use SGX in the real world for a long time. But I have not yet heard my first credible rumor that that's happened. But if anyone out there hears of anyone actually using SGX for anything, you can leave us a tip on the Hacker Helpline at 206-486-NARC. That's NARC. 206-486-NARC. Thank you.
Good call out.
So Hyperledger, a blockchain style project, that they mentioned by name in the presentation, is considering integrating a consensus mechanism called proof of elapsed time, which makes use of SGX attested secure enclaves. And essentially, if you can attest that all of your consensus mechanism code is running in an enclave, and you can verify that every time there's a block update to your sort of shared data store, this allows you to basically emulate what Bitcoin does by trying to find the right nonce in order to meet a difficulty bar. So basically what you do is that everyone picks a random number, everyone sleeps for that amount of time, and then everyone sort of sends their update, and the first one to do it wins. And as long as everything was running in this sort of enclave that you can attest is all running the same code, this might actually work for your use case. I don't know. I'm not in a need to ever care about any of that, but maybe someone does. I don't know.
I think the critical point on that is that there's not the proof of work function isn't really related to the elapsed time. That's not the important factor there. It's really to ensure that the that one block follows the other block without any interruption. So really, like if you were to try and if you were to take that concept of running everything in the secure enclave and just actually have the block appending block append run in the secure enclave, that would provide similar similar mechanisms without having to wait and like spin lock
Sure,
on.
you'd have to figure out who decides on who the first leader is, and so there's like a bootstrapping issue. But yeah, that could all be solved probably.
I didn't catch during the presentation that HLF was the partner that was considering this, but it does make sense that the enterprise, the pseudo open source, pseudo closed source enterprise blockchain partner that uses Apache Kafka as its consensus mechanism.
Wait,
Well,
you gotta come back to that. Go on.
Would be the one that would actually consider
that would Apache Kafka as part of its consensus mechanism.
that would now be considering Poet as an alternative mechanism.
You said Kafka, not Zookeeper.
Yeah.
But Kafka is a log aggregator.
Uh-huh.
What? How does it? Does that?
Technically, Apache Kafka is now expanded itself into a generic stream processing framework for Java.
But it doesn't do consensus.
No, correct. That's the
How
joke.
do you even? Okay. All right, I'm letting it go.
This sounds like proof of Rochambeau.
My blood pressure alert's going off.
So
Proof
yeah,
of
there was
Rochambeau.
that.
Wait, so proof? How do you do distributed proof of elapsed time? Like I'm stuck on that.
So it's distributed.
How is it? How is it time? How is it? So like proof of work, I understand, but proof of elapsed time is tricky on distributed hardware. What are they synced with NTP? And then they're all trusting their local NTP server?
Well, so
how do they even know what time it is?
So
It's
basically you have to. All you need to be able to prove is that a sleep function occurred for this amount of time with some error bounds, and it ran in an enclave.
Not your OS sleep though, because that's.
But how does it? So it trusts that the sleep function hasn't been hooked to just return immediately because it trusts that it's in a trusted enclave.
Yes.
Yeah, the entire sleep
Right?
function has
Yes.
to be within the enclave, so it's probably just like an idle loop.
So not all enclaves have reliable clocks.
No, it's probably an idle loop. It's probably like it's probably just like spin for like execute nops for 30,000 instructions, or add one to this counter 30,000 times.
So what? That seems silly. What would I get out of it if I can like convince it's in a safe enclave and it's not, and then lie about the timer? Do I get free?
You break whatever
crypto coins or something?
Well, right. They said that
This should not be used for money. This is they
Yeah.
explicitly stated as such.
Yeah.
That's how much confidence they have in this.
This sounds
yeah.
ridiculous. Can I somehow get
I first heard
extra
about this
money?
2 years ago. But I remember when I first heard about it, and But now it's making its way up through the marketing diagrams and out there to the people.
But its name is Poet, so obviously it has to be very.
Poet was the name of the padding oracle attack in .NET that Julian Rizzo came up with like 10 years ago, approximately. No,
Yeah.
not quite. A little less than that. It was like 8 or 9. But you remember, like the view state encryption was totally hackable for a while. Yeah, that was a good time.
So I do want to call out some very good talks that you should go and watch once they're released.
Yeah.
One of them was, let's see here, Linux boot, so progress. So basically someone talked about, here's what we could do with Linux boot, and one of the things that they did was, it's a basically bootloader that is Linux, and they wanted to say, hey, can we boot Windows from Linux? And they built a bunch of sort of modules that emulate what an EFI runtime would give, and they passed those in the right pointer structures, and then they called kexec on NTOS kernel, and it all ran, and they got it to boot eventually.
So they ran. So years ago, people ran Linux as a coprocessor inside Windows. but like Co-Linux was the project. This was
Right.
like even before
Yes.
virtualization was a big thing.
And now Ubuntu.
And now they've apparently run Windows inside of Linux. Yes?
No, it's KExec.
It depends on your definition of inside.
KExec replaces the kernel. So it's you.
So it's basically chain loaded.
Yeah,
Yeah,
it's chain
exactly.
loaded.
Yeah.
I mean,
Well, that's okay. I mean, Zen is kind of Linux also, right?
Right. Yeah. So that was a fun talk. Definitely worth checking out. There was an individual from IBM who gave a presentation about sort of. I believe this is the one. So yeah, protected execution facility by I do not want to butcher this individual's name, but from IBM Research. And so they came up with the concept of secure virtual machines, and they built basically a protected ultravisor extension into the PowerPC architecture.
Protected ultravisor.
Right,
Is that what
yes.
PowerPC calls hypervisors? Is it ultravisors?
The protected execution ultravisor.
Are you... So he just slapped... He went up
I'm gonna go
from
trademark
hyper
Megavisor
to
real
ultra
quick.
and then just slapped secure in front of it. So how does it use the blockchain?
Right. So this all sounds very like haha, very funny. But this
Well,
individual.
it's more of a sad, funny...
Well, the thing.
It's like every time you hear the
you
word
think
cyber.
that's what it says on the
Yeah.
label. But the presentation was excellent. It was very technically in-depth and detailed about what the system could do and what it couldn't do. And there was like an hour-long Q&A session after
Nice.
with folks asking very detailed questions about, well, what about this use case? Will it support this use case? Is this property actually true or not? And at the end of it, a lot of folks were like, yeah, that was actually surprisingly sane. So
Cool.
definitely worth checking out.
Do you know if they'll have the Q&A sessions in the videos?
Yes, they
Yes, they
explicitly
do.
made
That's
sure
my-
people got microphones during the questions so that,
Yep.
Excellent.
yeah.
So what was the title of that talk?
I believe it was Protected Execution Facility. That's just a very sort of
Protected
esoteric
execution
name.
facility.
Yeah.
That sounds dark.
Right.
like you would get renditioned to a protected
Anything-
execution facility. You said that was IBM, right?
Yeah.
Jeez.
Ultravisor.
Right.
They haven't lightened up much.
All of the stuff about OpenXT and sort of like all of the MicroZen stuff was very interesting. A lot of open source projects trying to build better
Wait,
open hypervisors.
So MicroZen is a thing? Is that
Yeah,
like
MicroZen
is that like if you meditate really quickly?
it's a stripped down version of a Zen in the Linux kernel to provide just the barest amount of hardware support. Instead of having a full DOMU with everything, you just have the barest.
Right, so there were a number of what I was colloquially referring to as toy hypervisors, but that's not fair to these projects. Basically, what they're looking to do is try and reduce a significant amount of complexity from the hypervisor itself in order to implement a more integral virtualization, usually for embedded use cases mostly.
I haven't seen as much interest in hypervisors as the future so much as containers. And I've been sort of wondering if that is in sort of like a shared hosting scenario, are containers more performant for a large number of hosts? They must be, right? Because they're basically sharing the kernel and they're just sort of forking the same kernel into sort of multiple containers, right? Whereas with the hypervisor, you're sort of you have to mirror the whole operating system on everything.
That's correct.
right?
It's also they're a lot easier for developers because you can git clone a container quite easily. You can't git clone a whole disk image and run it in a virtual machine very easily. You have to set up the virtual machine. You have to do all this preload work in order to get that right.
So to set up a container, you only need to configure the differences from the stock kernel's config, and you're sharing the same
You
kernel,
don't even need
right?
to do that really. It's handled by
Yeah,
this.
well, like a Docker file or whatever.
Yeah,
Just,
exactly.
like you have some
It's
script
included
that just
with
runs.
A lot of the Docker stuff too is pretty agnostic of like what the details about the kernel too.
Yeah.
Yeah, a lot of times when people think they're using Docker, there's actually, hypervisors that actually Docker abuses
If
in
you're
order
not
to
on
be
Linux,
able
for
to
example.
in order to implement a consistent user experience. So in reality, like Docker will be very selective about when it's a container system and when it's a hypervisor.
And also the
based
definition
on
of
where it's-
container just kind of sucks. It's like, we had some C group stuff here and we had some like
syscall whitelisting, blacklisting here, and we had some namespace stuff here, and we kind of threw it all together, and we gave it the word containers, and it's like no one actually knows like.
It's like when you it's like they made chroot a bit better, and then they made it a lot worse by connecting it a lot more.
The secret is to just keep making things more complicated until nobody knows how to do anything.
And
then pen testing will be easy.
I mean,
forever.
by that logic, we've already kind of hit that threshold many times over.
That's why I was using the sarcastic.
After you do that, you have some portions of your software chain developed in one place, and then you compose those at the lowest cost with other parts, and then you sort of like have this whole chain of custody of your software that you develop that you may or may not care about auditing. And actually an individual from Carnegie Mellon who had basically, I'm sure he knows many folks who work at CERT that manages sort of like incident response for and vulnerability reporting for a lot of official folks in the United States, gave a talk about managing the software supply chain.
This is Daniel rant time.
I think we're going to cover that a little bit later in the segment, but the fact that there's members of the security community now finally realizing that we have a supply chain problem in software, and as if that was magically the manufacture and process of producing software was going to be in any way significantly different from the problems we've already experienced with manufacturing physical goods is mind-boggling. But that actually wasn't the thing that made my face melt in that Well, first off, a lot about what he was pushing from a vision standpoint is something that I fundamentally agree with. I think we do need better attestation, better artifacts, better provenance when it comes to what actually goes into the sausage, what goes into the software that you're consuming and then you're putting on whatever the hell you want. But I think the part that made my face melt the most in that presentation is this individual happened to let be known that that NIST and NVD and I forget what other organization, CERT, was in a situation where the volume of submissions they were receiving was exceeding their capacity to process. And so while we have elected that to be the standard body by which we report issues to for process and then notification to the general community, they're actually failing silently. They're sitting on 17,000 plus records. I don't remember the number off the top of my head.
I thought it was 10 times.
It quite possibly could be, but
so it's somewhere between 17,000 and 170,000.
Yeah,
neither of those numbers are good.
The way that I factored it into my head is at least a year's worth of publications in CVE numbers.
So those are vulnerabilities reported to the Central Vulnerability Clearinghouse
that have not been processed and turned into general publication access, which is mind-boggling to me.
Yes. So, I mean, this is sort of a similar situation to crime labs being backed up by years, right? With like DNA tests. Although, I mean, this is just computers, so...
I mean, to be fair, like anyone who is significantly paranoid would already have expected some element of this to be the case,
yes.
Just because of the dysfunction of what?
Well,
that's
so they would say
news
it's
at 11.
Funding, but
it's always
funding. It's always funding.
But this actually, there's a long history of just paying lip service to functions and then not funding them because you don't really care. And the example that always that I always hearken back to when thinking about this particular topic is there is a federal agency which is responsible for enforcing truth in advertising. There still is to this day. And in the early days of the Reagan administration, he didn't kill that agency because that would have been unpopular. People would have been like, why are you doing away with this? They're doing this important function of enforcing truth in advertising, right? What he did instead, because, this is as the head of the executive branch, he can just change budgets. He just cut their funding until it was like 10 people.
Yeah.
So all through the rest of the 80s and 90s and maybe even to this day, I don't think any other president has been like, yeah, we should fund truth in advertising more because that'll be popular with my business constituents. Like, that doesn't happen. But for all of my formative years, the sugar cereal toy advertising years, like the enforcement of truth in advertising was completely unfunded, and therefore everybody lied in ads. And in the unlikely event that they were penalized for that, the fines were so small they just paid them, right?
Which is ridiculous. You would think when they get their funding cut that they just increase the fines, and then they can they can make the money to hire more people to.
Now you're thinking like a DARPA engineer. You want a self-healing system.
Like a DARPA engineer. That's how the city works. What do you think police are for?
Isn't that also how like the Norwegians do speeding tickets or something? It's like proportionate to your income.
It's proportional.
Maybe it was Sweden.
Finland.
It's probably all three.
Probably
Dancing
three, yeah.
around the Nordics. Yeah. So that was basically, if I want to sort of summarize the talk by this summary sort of little essay that was written by the soft-spoken mastermind who got all of these people into this one place for 3 days in Redmond. And the title of this essay is "We Want to Believe: Hardware Fan Fiction, Supply Chains, and Platform Security." And I won't read the whole thing, but the second paragraph is just money. And so here it is. If trust but verify is the motto of information security, buy then believe could be the motto of modern mass production and post-purchase regret mitigation marketing. Volume creates self-fueling economies of scale. With sales volume driving profits for research and development, even initially weak implementations can eventually narrow the gaps between marketing, engineering, customer beliefs, and attacker observations. And so the rest of this article goes through and sort of discusses that, the future of hardware is already here. The electrical chip foundries are already doing their things on the next iterations of chips that none of us mortals have any idea what's coming. Things are getting more complex. Is that the only way to go? Can we start moving our complexity specifications down in smaller ways and compose them in sane ways? Will that be commercially viable if we think about doing that? And so a lot of very important questions that were asked and someone answered, but not sufficiently, in both this essay and this conference, and very grateful to Rich and all of the other folks who put this conference on.
It's interesting to me that he raises complexity as the core issue, because that's something that I also bring up a lot. The assumption that you will be able to hire arbitrarily skilled tech workers in this environment is not a safe assumption at all. And
it's a very dangerous one.
Yeah, it's not really possible. There's so much more demand for tech workers than there is supply, that everybody ends up hiring. They lower the requirements on who they hire, and that's great. That's actually, in some ways that's really good, because it's letting a lot more people into the tech industry. And I think long term, that could have really positive effects. But in terms of making sure all of the, making sure everything's right, people without a lot of experience don't necessarily know all of the things that can go wrong, because sort of what experience is seeing a bunch of stuff fail over a long period of time until you get a sense of how that usually goes.
Yeah, so
right, that's more or less what experience means, at least in this industry, where we don't learn how to carve anything or anything like that. So it's basically just like pattern recognition of screw ups.
Right,
that's sort of the skill.
It's pattern recognition on both patterns and anti-patterns, and the way that I've often sold it to individuals that I've had the pleasure of contributing to their growth is I say the difference between this role being a security engineer or whatever label you apply to it in other organizations, versus a software development engineer. In a software development role, you learn through peer review of the code you write. You learn from your own bugs, and individuals instilling wisdom and knowledge from mistakes that you make. As a security engineer, if the organization's built properly, you're learning from the collective mistakes that you review of everyone else's code. And so there's some, speed factors you get there for growing someone's skill set.
I just think looking at complexity and sort of relative skill level or training experience level of workers, there's sort of two ways you could go. You can let things just continue to grow in complexity until it's arbitrary, and you need this, monk class that can actually get their head around everything because they've devoted the last 20 or 30 years of their life to just figuring out like what all these weird symbols mean, or like what when the lights are blinking bad, right?
Yeah.
Like they know because they've spent 30 years at it, right? Or the other way you could go, maybe and I think that's already not realistic to expect you can even find one person like that in any given context, right? So
Right.
the other way you can go is, given that you have a bunch of people that are interested in getting biosurvival tickets to like look at the blinking lights, maybe it makes more sense to try and simplify things, to provide some primitives, some sort of atomic functionality that can be used safely without that much depth of knowledge. And as much as people complain about Node.js or Electron, and by people I mean me, as much as I complain about Node.js, I have to admit, it's 75%, 80% of programmers are writing in nothing but JavaScript, and those are, and I say that like it's a bad thing. Like I'm stressing, hey, it's hard to find people that can like audit code in multiple languages or something. But realistically, those are people that probably have relatively decent paying tech jobs they wouldn't have had otherwise, and don't have to lift anything outside of the union requirements, or they probably don't have to get up at 6 o'clock in the morning.
That was I get the metaphor.
No. It's actually, that brings up something that we were talking about on the drive up here. Was that sort of this industry, like in general, like computer science, was a bit more of a trade industry, perhaps in the 90s, like where it's like you sort of are apprenticing in the junior state, and then like there was no real degree. I mean, like you could go to get a computer science degree, definitely, but but a lot of people that wasn't their path. And you can go to a trade school for like machining or something like that, but there's also the journeyman or the apprenticeship journeyman sort of role, but it's not really well established in
what kind of drives me crazy about the tendency of tech people is if there's an XKCD about this, when there's two conflicting standards, the tendency is to make a third standard that everyone can get behind, right? And then there's three conflicting standards, so then someone will come be like, oh, 4 standards, right? So with that tendency working to always make more complexity, always make more frameworks that do exactly the same thing, and always make the audience more fragmented. And with that happening at even the hardware level, at the like network level, like authentication primitives, like there are some narrow stripes of this where everybody more or less uses the same thing, but there is not a big countervailing force to simplify things or take things out or make things easier to use or more universal, and I think that where there are things like that, the effects have been sometimes positive and sometimes negative. Like if you look at OpenSSL, the plus side is that almost everyone is using OpenSSL, and OpenSSL people actually look for bugs and find bugs, and then the bugs get fixed. The downside is that when people find bugs, those bugs affect everybody, and tend to get pretty widely talked about very quickly. Someone will have a POC working, like the same day, next day. So there, it's the double-sided coin of homogeny and complexity, I guess.
I think that right there, I think is an important point to highlight, is that the relationship between homogeny and complexity, right? Like the reason why there is a perverse incentive in place that incentivizes engineers to create the third, fourth, fifth standard, and that incentive is backwards compatibility. That incentive is to ensure that whatever new solution you introduce does not destroy what already is in place. And I think I don't think we've solved that problem yet, period. Like, I don't think any one of the layers of engineering, like hardware, software, doesn't matter what layer you're operating at, I don't think we've fixed that.
Total side question. Is anyone really investing in technology moonshots, like no one's, there isn't, so Windows
like
did,
teaching like a thing of gas how to like do like transistors or something. What do you mean by moonshots?
like large long-term technical investments. So the best example I can think of is the NT operating system. Microsoft put a team on it for years and years, and they tasked with rewriting the Windows kernel, and they did, and it turned into NT, and it took a long time, and then that eventually became the mainline Windows branch.
I think all the moonshots right now are pretty much heavily invested in AI.
Yeah, so there's a lot of investment in AI, like blockchain, and that's probably not going way to be that useful. Actually, so with that, we'll take a break. Stay tuned after the break for useful hacking tips from our panel. While we're on a break, just a reminder that the fourth Friday of the month, Symbol Crash runs a free hardware hacking workshop. It's the fourth Friday of the month at the Prelude Institute on about 4th and Lenora in downtown Seattle. Look for details on Meetup by searching for Symbol Crash. All right, now let's take a call from the Hacker Helpline. So this is our very first inaugural call on the Hacker Helpline. If you have a question for our panel or about hacking in general, give us a call. Area code 206-486-NARC. That's 206-486-6272. All right, let's go to the phones.
Yeah, hi, this is Griffin. I just got a problem with a serious lack of episodes that have been released. One episode is not enough, man. What the fuck? Come on, give us some more content already. Also, you should have Griffin Howard on as a guest. He would be fucking sick. Thanks. Bye. Fuck you.
I think we should definitely do that.
Yeah. Although I think the self-promotion was a little heavy-handed there.
Yeah, let's wait and see. We'll have him on first and make that decision afterwards.
Yeah, that's fair. We can always delete the audio.
Seems like a fun guy. Well, so we, in terms of the sort of rate of content, or how frequently we'll try to get episodes out, like all true hacker projects, we decided to learn how to fly after jumping. So this has been a very rapid course in audio engineering and trying to think in a straight line and editing and all this. So we've made some very rapid improvements in our methodology, and we're learning a lot from talking to other people.
Like not interrupting people.
But it's a little difficult to promise any particular cadence at this point. But I think we're trying to aim for monthly. Yeah,
we do have a couple stored up that were early test recordings as well. That I'm not sure, we might try and cut it into some of the newer episodes.
So no promises, but we'll do what we can. We're definitely having a good time with this, and we have a lot of ideas for content, especially interviews for the upcoming episodes. We're definitely going to have some people at the CCC Congress at the end of the year, and hopefully we'll get some good interviews from that.
And if you're hearing this, then this is a new episode, so...
Yeah, that's a solid point. All right, well, thank you so much for the call, and if anyone else has... something interesting to say, or just funny, or I guess that's a high bar. Interesting. Give us a call, 206-486-NARC. And now back to our irregularly scheduled program. And we're back in the studio with our panel. For the next round of discussion, we're going to ask everyone for one useful piece of information or a learning aid for a hacker starting out, or a more advanced topic, your pick. Everyone ready? Yeah?
At least so.
All right, let's do this. Let's start with Daniel.
So I'm going to build off of the helpful tips that we gave in our last episode. There were a couple of compendiums of vulnerable software that could be leveraged for building custom exploitation. There's another one in the same vein, referred to as screwed drivers. These are signed third-party drivers that have known vulnerabilities present within them, so that you can smuggle your malicious behavior through the approved identity of another binary likely already on the system. That's called screwed drivers. They have a bunch of wonderful demo code already worked and available. You just pull it down from Git and have a good time.
Are those all platforms or just Windows? Or
Just Windows signed drivers. Yep.
that's good enough. So that's like the new version of Capcom.sys.
Yep.
You know what's funny is that I have like 50 tabs open in my phone browser of things that I wanted to remind myself to look into later, and the very first one opened a year ago or something is is a Google query. What is the modern version of Capcom.sys?
Yeah, it's screwed drivers.
Screwed drivers. I can finally close that tab.
You're welcome.
That's amazing. Okay, next let's go to Max.
Let's see. Sort of going off the one that I did last week is just read the man page. Like, there's too many people who think that they're proficient at Unix systems without actually just going out and reading the man page on your basic systems, like system commands, all of the the proper usage of sockets. There's people are using everything wrong these days.
I actually have a follow-on question to your helpful tip. What's your favorite abuse of a command line utility? Like, what's the favorite flag abuse case for a command line utility that allows you to do really hacky, terrible things?
Honestly, it's every time I've been on a system that has a sudo more or less or something, just hit an exclamation point and you have a shell. Or maybe not even sudo, like maybe your mod D is displayed with with pager. Any pager, you just hit exclamation point and all of a sudden you have a shell.
Fair enough.
And my tip from last time was the living off the land binaries, LOLBAS, or GTFO bins is the Linux equivalent, and those are both GitHub pages that have large collections of built-in functionality of tools you'll find on systems that you can abuse.
Very related. Also, I will say one man page in specific. SOCAT. SOCAT is one of the most useful programs on a Unix system. Get a lot of thumbs up here.
That's SOCAT.
Yeah, SOCAT. It's basically like Netcat on steroids. You can start up like any sort of server, reverse shell, forward shell. It's if you don't know about that tool, now you do, and you're welcome.
Yeah, SOCAT lets you do stuff with sockets, not just network connections. You can do it with local sockets.
Yeah, AF Unix or even pipes.
Pipes.
They got all sorts of stuff.
Yeah,
so we're not cracking the surface.
Like, so you know how Unix is a file-based paradigm or whatever?
Yes.
Yeah, so this is basically taking that to absurdity.
SOCAT. There's a lot of situations I've run into where SOCAT was really the only pre-existing program that would let you sort of man in the middle certain sort of pipe connections. Awesome. Those are some good tips. Oh, next up, Mitchell.
Cool. So I want to talk a little bit about browsing massive code bases. So,
a topic near and dear to my heart.
When I first started out in security, I was like, how am I going to find vulnerabilities in these massive, large code bases? And if that's something you're interested in doing, a good place to start is Mozilla Firefox, because they have a lot of open source tooling around this. And one of those tools is DXR, which is a publicly hosted service that is basically a really nice editor in your, not an editor, but like a
source code with annotations viewer that you can view in your browser. I believe it's like dxr.mozilla.org or something like that. And you can go there, you can type in any class name, you can also get like a nice little tree, you can search by symbols, you can search by things, functions, file names, what have you, which is cool, but it's a massive code base. And so one thing I like to do is look at the newer or more recently added functionality, things like WebRTC, web audio, web VR now, and web augmented reality, and what have you, and then correlating that against the Mozilla crash stats. So all Mozilla crash stats are all of the ones that are forwarded to Mozilla every time your browser crashes and it says, please send this to Mozilla, we'd like to improve the experience. Most of those records are scrubbed for what they can deem are personally identifying details and then sort of released in batches to this crash reporter site. So if you actually search for class and function names inside of the crash stats, you can find a lot of really interesting crashes that are happening in sort of newer versions of Firefox functionality, and then you can go on DXR and you can sort of search the stack traces that are pulling up, and it's a very interesting way to quickly get spun up on a sort of very large complex code base, and it's actually how I did some of my first work in bug bounty myself personally. That's my tip.
It's a really good tip.
That is a really good tip. So in the abstract, you'd start from basically if you have access to crash dumps, you'd start looking at the crash dumps and
correct.
Yeah. How often? Okay, cool. So next up, I guess, is mine. I'm going to shamelessly plug one of my own projects. So this is more in the red teaming sort of pen test domain. It's sort of less useful for defense. This is something that's going to be featured in the symbol crash training in December. Several years ago, actually more than 10 years ago, Josh Pitts wrote a very famous program in Python called the Backdoor Factory. And the Backdoor Factory worked with Ettercap. So you could set up a ARP poisoning attack, man-in-the-middle traffic, and then route it through Backdoor Factory. Backdoor Factory would intercept all web downloads, pick the binaries out of them, and inject them with the shellcode of your choice. Now, this was very popular with red teamers back in, I want to say 2007, maybe through 2009. At some point, the code rotted. It does not work on the modern, it doesn't work on the modern version of the operating systems. Although I should have mentioned that one of the other really neat things about Backdoor Factory is that it included injectors for all binary formats, for ELF, for PE, and for Mach O, for Linux, Windows, and OS X. So in the course of this year, me and my group have rewritten Backdoor Factory, refactored it, ported it into Go, and broke it into logical modules so that they can be reused. So we have a separate library now that parses all binary formats, allows you to make changes, and then regenerates the binary. And then we use that to actually implement our injection methods. So all of this code is public at github.com/binject, capital BINJECT. And the subrepo is binjection. So in binjection exists our rewrite of Backdoor Factory called BDFNG at the moment. As well as in the binject group are the parsing and regeneration libraries for all binary formats that you can use to write your own injections. And additionally, our rewrite of Backdoor Factory works with the Go rewrite of Ettercap called BetterCap. So in addition to easily setting up ARP poisoning attacks, you can also set up other sorts of man-in-the-middle attacks, including DNS poisoning, and all of the other capabilities that come with BetterCap. So in terms of and we're going to be doing some other really interesting modules and stuff for this framework as time goes by. So keep an eye on that. And with that, that does it for our nth episode. Thank you for listening to the Hack the Planet podcast. And let us know what you think by leaving a message at the Hacker Helpline, 206-486-NARC. That's 206-486-6272. Or email podcast@symbolcrash.com. And remember, hacking isn't just a crime, it's a survival trait.